In this lesson, we're going to start talking about quadratic relations and what their graphs look like. So we've talked about quadratic relations in class already, but we called them degree 2 equations. So that would be equations like this, where the degree is 2. When the degree of y is 1 and the degree of the x variable is 2, it will always make this shape, and this shape is called a parabola. You can see how to write parabola right there. So this shape is a parabola. It can open up like this, or it can open down like this. If it opens to the side, this is another shape, it's another graph, but it's not a parabola. So this one is not a parabola. Parabolas can either open up or open down, and they always are formed when you have a degree 2 equation, so a second degree equation, where the x variable is squared but not the y. There are two important features of this new graph called a parabola. One of them are its x-intercepts. Parabolas can have up to 2 x-intercepts. As you see, it intersects, this shape intersects the x-axis 2 times. The second important characteristic of a parabola is this new word called a vertex. A vertex is the very lowest point of a parabola, or if it opens downwards, the vertex is going to be the very highest point of a parabola. It's the point of the parabola where the parabola changes direction. So here it's going downhill, and after the vertex, it goes uphill. Here it's going uphill, and after the vertex, it goes downhill. So what we're going to talk about in this lesson are how to find these two very important parts of this graph, x-intercepts and a vertex. So let's talk about the characteristics that we're probably most familiar with, which is x-intercepts. So something that's really important is there's different words to say x-intercept. So most commonly, we use the word zeros or roots. Zeros and roots mean x-intercepts. So if a question asks, find the zeros of this parabola, that means find the x-intercepts. Also, if a question said, find the roots of a parabola, that means find the x-intercepts. So we're going to practice using these words interchangeably. Zeros, roots, and x-intercepts all mean the same thing. So let's take a look at this first example. It says find the roots of this parabola. So how do we know this is a parabola? Well, first of all, it's a degree 2 equation, and the y variable has a degree 1, and the x variable has a degree of 2. That's the highest exponent. So we know it's going to make a parabola. And it says to find the roots. So we know that finding the roots means find the x-intercepts. So make a note of that for yourself. Roots is x-intercepts. So you actually know all the tools to find this because we practiced it already. We just have to figure out what do we know about x-intercepts. So let's take a look at this picture of a parabola. These 2 points have something in common. All x-intercepts, their x values will change, but what is the y value of an x-intercept? Well, the y value of this point here is 0. And the y value of this point here is also 0. In fact, any point along the x-axis here will have a y value of 0. So really important, when we have to find the x-intercepts of a parabola, we need to write a note immediately that if we're finding x-intercepts, that means y is equal to 0. That's so important that we write it every time we see that we're finding x-intercepts of any relation. So if we have to find the x-intercept here, the first thing we're going to plug in is y equals 0. So instead of y, I'm going to put 0, and then we've got x squared minus x minus 12. So now that we have put in a 0 here, this equation is going to give us the x-intercepts. Now the question is, how do you solve this equation? And this is where you shouldn't need me anymore, because you should be thinking, I cannot solve this with grade 9 methods because I can't get the x's by themselves because there's an x squared there. So what do we got to do? Hopefully you're saying factor. We got to factor. Note that there's nothing in common here, so there's no common factor. We can use decomposition, and we can also use the shortcut of decomposition because the a value here is 1. So let's use the shortcut of decomposition. We're going to look for two numbers that multiply to -12 and add to -1. Let's find those numbers. It has to probably do with 3 and 4. 3 times 4 makes 12. Which one has to be negative so that they add to -1? The 4 has to be negative. If you have trouble with this, please go back to the decomposition lesson. So now let's continue to factor, and we're going to use the shortcut. We're just going to put our two brackets. I'm going to put an x in each, and I'm just going to copy down the numbers that we found, +3 and -4. And so now we can solve this equation. What is the answer here? What can I plug in right here so that something +3 makes 0? And the answer should be -3. How about right here? What can I plug in right here so that something -4 is equal to 0? That something has to be 4. So what did we find? We were solving for the x-intercepts of this parabola. So we know for x-intercepts that means y is equal to 0. So that's what we plugged in first. We solved by factoring and got our solutions. If we wanted to do a sketch, here's what it would look like. We have one x-intercept at -3 and one x-intercept at 4. I'm going to put those points on here. We got -3 and 4. I'm going to put two big dots right there because we know that those are points. And let's connect this to look like a parabola. The question is, though, should the parabola look like... Oop, I made a lightsaber. Should the parabola look like this, where it opens down, or should the parabola look like this, where it opens up? I'm going to teach you a trick, which is that whatever number coefficient is before the x squared term, so we call that guy a. So remember, we called this guy a, so the 1 is a, the -1 is b, and the -12 is c. So this guy right here, a. If a is positive, the parabola opens up. If a is negative, the parabola opens down. So you can see that this a is positive, so the parabola opens up. So I'm going to connect it like this, and this is what our parabola would look like. Can we do the same for the next one now? So try this one on your own. I want you to find the roots of this parabola. Use this as an example. So right now, pause the video and try it on your own and come back when you think you have it. If you're back at the video, you should have tried this on your own. First check, since we're looking for an x-intercept, did you write down that you knew that y is equal to 0 because it's an x-intercept? So here's the first line that you should have on your sheet. 0 equals 6x squared minus 8x. And now we have to solve this. We have two x terms. One of them is squared, one of them is not. We cannot use our grade 9 methods to solve this. We have to solve this using factoring. What type of factoring did you choose here? Well, we always have to try the first type of factoring first, which is greatest common factor. These do have a greatest common factor. It's 2 and x. If we take out a 2 and x, we're left with 3x minus 4. And now we can solve this. 2 times something times all of this is going to make this equal to 0. What does this something have to be? 2 times what makes 0? The answer is 0. So one answer is 0. How about this one? How can we come up with this solution? We've done this in class many times. We just set this equal to 0 and we solve it. 3x is equal to positive 4. Divide by 3, divide by 3, and x is equal to 4 over 3. So that is our second answer. If you were to quickly sketch this, here's what it would look like. I'm going to put a big dot at 0, since I know one of my x-intercepts is 0. Also, I'm going to put a big dot at 1.33333, because that's what 4 over 3 is equal to. I have another x-intercept right here. Now the question is, does this parabola open up or does it open down? Well, what is our a value? Our a value is 6. That's a positive number, so this is also going to open up, just like this. Now let's learn about another characteristic. This characteristic is called the axis of symmetry. So the axis of symmetry is just the vertical line that runs through the parabola that cuts it in half perfectly. We can see, if we go to our original picture right here, the axis of symmetry runs just through the middle of the parabola, cutting it in half exactly. The axis of symmetry is really important because the vertex is on it. So if you have an axis, if you have a picture of a parabola, it's really easy to come up with the axis of symmetry because you just have to find the vertex. Let me put a big dot at the vertex, and you just have to draw a vertical line down this vertex. So the question is, what is this line called? Well, this line is called, what is the x value here? This x value is 1. So that means that this whole line is called x equals 1, because all along the line x is equal to 1. So we're going to call this x equals 1. Can you find the axis of symmetry of this parabola? Well, first find the vertex, here it is, and then draw a dotted line all throughout, all down the middle of the parabola. So that is our axis of symmetry. So let's name it. This line is a vertical line, so it has to be called x equals something. And what is true all along this line? What is true is that x is always going to equal -5. X is equal to -5. So this was really simple, but it's not always going to be this simple. Sometimes we're only going to be given an equation and not a picture. So we have to start thinking, how could I find this number if I didn't have a picture? Well, the key is that if you have the two x-intercepts, you can always find the equation of symmetry. Here's what I mean. Let's list out the x-intercepts. What are the x-intercepts of this first parabola here? Well, we have this point here. That is -2. So I'm going to write -2 as one of our x-intercepts. What is the x-intercept here? The answer is +4. I'm going to write that as our second x-intercept. So what we have to find, we're finding another way to find the axis of symmetry when we don't have a picture. See these two x-intercepts? The axis of symmetry runs in the middle of the parabola. So if we find the middle of these two numbers, the middle of this x-intercept and the middle of this x-intercept, we will always be given the axis of symmetry. So the question is, how do you find the middle of these two numbers? To find the middle of those two numbers, we just have to find their average. What is the average of -2 and 4? All you have to do is add them together and divide by 2, and we should get the same answer that we found visually. So I'm going to add -2 plus 4, that makes 2, divided by 2, and it makes 1. Perfect. We found the same axis of symmetry. How about finding it here? If we couldn't see it visually, as long as we have the x-intercepts, you can find the axis of symmetry. So I'm going to put a big dot at this x-intercept and a big dot at this x-intercept. This x-intercept is -7. This one is -3. So if we add them together, -7 plus -3, so that's going to be like taking away 3, and you divide it by 2, it should give us the exact same axis of symmetry that we found visually. Negative 7 minus 3 is negative 10 divided by 2, and x is equal to negative 5. And you can see we found the same axis of symmetry that we found visually. So far we've talked about all these new properties of a parabola. We've talked about the x-intercepts. That just uses tools we already have, which is factoring. The most important thing is y is equal to 0. Now we talked about the axis of symmetry. That's just going to be the line that cuts the parabola in half. And it's going to be the middle of the x-intercepts. That's where it's going to be located. Now let's talk about the vertex. So this first guy, really simple, just from the picture, can we list off the vertex? So here is the vertex of this parabola. And here is the vertex of this bottom parabola. The question is, what is that point? Well, that point is positive 1 and up 9. So let's list out here. It's positive 1 and up 9. And the question is this a maximum or a minimum? So this vertex is the highest point on the parabola. This vertex is the lowest point on the parabola. Let's list that, by the way. That point is going to be negative 5 and then negative 4. So we're going to write that point down, negative 5, negative 4. And then it asks for the max or min value. This parabola has a maximum value. It's the highest point possible. This parabola has a minimum value. What is the max value though? Is the max value the 1 or the 9? Well, 1 is not the biggest x value. The biggest x value, there's an infinite number of x values. But the y value 9 is the absolute highest y value. Just like here, this is going to have a minimum value. This is the smallest value that it has. But which is the smallest? Is it x or is it y? And y is the smallest. So when it asks you for a maximum minimum value, it's asking about the y value, not the x, just the y value. So this y value is 9, and it's the biggest y value possible, so we say it's a max. And the maximum value is 9. So not the x value, the y value. How about here? This vertex, because this parabola opens up, is the smallest value possible. What is the min value? The minimum value is negative 4. So now that we've read off the vertex and we understand, or we've done some examples of what a maximum is and what a minimum is, we're talking about the y values. Now let's put all of these pieces together and solve a problem. So here's our final examples. Here is an equation. You can see we're not given any picture. And it says find the vertex of this parabola and then sketch it. So we have to figure out how to find the vertex of the parabola. So try to use these steps to help you. Remember that we can find the vertex as long as we have the axis of symmetry. If we know the axis of symmetry, that gives us information about the vertex because the axis runs through the vertex. So here's the key. If we find the zeros first, so if we find the x-intercepts first, this guy and this guy, and then we use that to find the axis of symmetry second, so we have this line here, then this vertex, the x value of the vertex will be the axis of symmetry, and then we're going to find the y. So what we're going to do is we're going to find the x-intercepts, we're going to use the x-intercepts to find the axis of symmetry, and then we're going to use the axis of symmetry to find the vertex. So here we go back to that list if you need help with it. So if we want to find the vertex, the first step is find the zeros. And your teacher is so nice, I've already factored this for you. So if it's not factored, you're going to need to factor it, because if we're going to find the x-intercepts, then we need to plug in y is equal to 0. So for x-intercepts, that's going to be our first step. Find the x-intercepts. And we know to do that is y equals 0. So let's do that. Let's plug in y equals 0 first. And then we have x minus 4, x minus 2. I've done the hard part for you. I've already factored it. So now we can pull out our answers. So the answers to this equation are, we plugged in y equals 0, 4 and 2. So we have two x-intercepts. They're 4 and 2. Let's plot this as we go. So our first x-intercept is 4, big dot here. And our second x-intercept is 2, big dot here. So we are trying to find the vertex. So what is the next step? Well, the vertex has to lie in the middle, exactly in the middle of these 2 points. So how do we find the middle? Well, that just means we're going to be finding the axis of symmetry. So let's find the axis of symmetry. And we practiced how to do this without a picture before. All we're going to do is find the average of the x-intercepts. So add the first x-intercept and the second x-intercept and divide it by 2. And that's going to give us the axis of symmetry. So let's do it. So the first x-intercept is 4. The second one is 2 and divided by 2. What is in the middle of 4 and 2? Well, if I add 4 plus 2 together, I'm going to get 6 divided by 2. The answer is 3. If you can just figure that out in your head, you know what's in the middle of 4 and 2, it's 3, then that's great. So I'm going to put a dotted line all down the line, x is equal to 3. The third step now, just thinking about this logically, or you could use the list on the other page. Now that we found the x-intercepts and we found the middle of them, we know something about this vertex. The vertex has to lie somewhere along this line. So if it has to lie along this line, then we know that the vertex x value must be 3. So let's find the vertex now. The vertex, and we know a clue. We know that the clue is that the x value of the vertex is equal to 3. So we just have to find the y value. So all we're going to do is take our original equation and plug in x is equal to 3. And we can find out what the y value is, and we can find this point. So I'm going to start with our equation, 2x minus 4, x minus 2, and I'm going to plug in 3 for x. So I have y equals 2. Instead of x, I'm going to plug in 3. And again right here. And I have this going to make negative 1. This is going to make positive 1. So this y value is 2 times negative 1 times 1 is negative 2. So we have a point. So the vertex is going to be at when x is 3 and y is negative 2. X is 3, y is negative 2. So I'm going to plot that now. 3 and negative 2. Big dot here. And now I have the vertex. That's what the question was asking. And it also said to sketch it. Now I can connect this into a parabola. And you can see that this parabola opens up. Should it have opened up? We'll take a look at this a value. If we were to expand this all, this would be the a value. And the a value is positive, so it opens up. If that went too fast for you, go back through that question and pause it where you needed the extra time. If you feel good about it, I want you to try the question at the bottom on your own. So right now, pause the video and try B on your own. If you're watching this now, you should have tried B on your own. So let's take it up. Okay, so here's what you should have gotten for your x-intercepts. You should have plugged in y equals 0 and solved this equation that your wonderful teachers already factored for you. So we would pull out the answers of negative 2 and positive 4. I've also graphed them on here. The next step would find, we're looking for the vertex, and we know it's going to be in the middle of those 2 points. So we're going to find the axis of symmetry. Let's take that up. We know the axis of symmetry is in the middle of the 2 x-intercepts. So if you add the x-intercepts and divide by 2, you will get x is equal to 1 as the axis of symmetry. And I've sketched it here. Now we're ready for our last step, find the vertex. We have a clue about the vertex. We know it's somewhere along this line. So our hint is that we know that x is equal to 1. And now we just have to find the point where x is equal to 1. Let's take that up. If you plug in x is equal to 1 into your equation, keep following my lines, you should get y is equal to 4.5. So we have the point of our vertex. That means that the vertex is when x is 1 and y is 4.5. Let's sketch that. And once we've sketched the vertex, we can connect it in the shape of a parabola. And you can see that this parabola opens down. Does that make sense for our equation? Let's look back at the equation here. The a value is right here. If you were to expand this all, our a value would be negative 0.5. So our a value is negative, and it is opening down. So we know that this must be right. So in summary, we learned all these different characteristics of a parabola and how to find them. X-intercepts, axis of symmetry, and vertex. If you were confused at any part of this video, go back and slowly rewatch it and then start your practice.